Here we have problem number 1 from chapter 4. At what angle is the first minimum for 550 nanometer light falling on a single slit of the width 1 micrometer? Okay, so previously we were talking about double slit. We had certain formulas for constructive destructive interference, but however for this time it's single slit, so it's slightly different things. So let me write down the given values. So basically it's the first minimum at what angle. So we have to find a theta in the first minimum. So that means m is equal to the 1 first minimum for the lambda, which is 550 nanometers. Single slit with the width of 1 micrometer. Okay, so how can we find it? Now before starting, let me draw how things look like here. In the single slit we have a single slit here, so this width is called D, and then we have here screen. It's far away, so this distance is L. What will happen is, so this is a central axis, and then you have the peak. Okay, so you have the maximum peak here, peak here. Okay, so then you have this angle. So let's say this is your theta. Okay, this is your theta. This is your central maximum. Now we have m's. Okay, so this is m is equal to 1. Here you have m is equal to 2. And in far away, so the farther it's m equal to 3, and so on. Okay, so then we have, for the single slit experiment, we have a formula where the formula is defined as d sine theta is equal m lambda. So we call this one as a destructive interference for the single slit. Okay, so by using this formula we can define what is unknown. So the theta will be here, sine theta is equal m lambda divided by d, and then from here theta is equal inverse sine m lambda divided by d. So the m is equal to 1, lambda is equal 550 nanometers, so it has to be an SI unit, which is 550 times 10 to the power of minus 9 meter, and this d has to be equal to the 1 times 10 to the power of minus 6 meter. Okay, by plugging them you should get the answer.